Welcome. Today we will be looking at cache mapping. After completing this session, you will be able to define cache memory, describe the link between the CPU, cache and main memory, and describe the characteristics of cache. What exactly is cache memory? Cache memory, or sometimes called cache store or RAM cache, is a portion of memory made of high-speed static RAM, or SRAM for short, instead of the slower and cheaper dynamic RAM, or DRAM, used for main memory. Memory caching is effective because most programs access the same data or instructions over and over. By keeping as much of this information as possible in SRAM, the computer avoids accessing the slower DRAM. This diagram shows that cache sits between the CPU and main memory, and that the closer it gets to the CPU, it gets faster. Here are the characteristics of cache. Location can be on the CPU, inside or outside. Capacity, the size of the word in the cache. Unit of transfer, internal, external, or addressable unit. Access method, sequentially, directly, randomly, or associatively. Performance includes access time, memory cycle time, and transfer rate. Physical type, semiconductor, magnetic optical, among others. Physical characteristics includes decay, volatility, erasability, and power consumption. Organization looks at the physical arrangement of the cache. Here are some terms you should know before watching the mini-series. A block. A block is a group of neighboring words in memory identified by bits of addresses excluding the word bits, which is represented by the letter W. Locality of reference principle. During execution, memory references of both data and instructions tend to cluster together over a short period of time. Examples of instructions that might cluster together are iterative loops or functions. It might even be possible for a compiler to organize data so that data elements that are accessed together are contained in the same block. Spatial locality. Given an access to a particular location in memory, there is a high probability that other accesses will be made to either that or neighboring locations within the lifetime of the program. Temporal locality. This is a complementary component to spatial locality. Given a sequence of references to n locations, there is a high probability that references following these sequences will be made into the sequence. Elements of the sequence will again be referenced during the lifetime of the program. Sequentiality. Given that a reference has been made to a particular location S, it is likely that within the next several references, a reference to the location of S plus 1 will be made. Sequentiality is a restricted type of spatial locality, and it can be regarded as a subset of it. When data is requested by the CPU and it is not in cache, it is referred to as a cache miss. If this happens every time data is requested, the cache would have a hit ratio of 0. When data is found in the cache, it is called a cache hit, and the effectiveness of a cache is judged by its hit ratio. If this happens every time data is requested, the cache would have a hit ratio of 1. A block of memory handled by the cache is called a cache line. The size of these blocks are called the cache line size. For example, 32, 64, and 128 bytes. A cache can hold a limited number of lines, determined by the cache size. For example, a 64 kilobyte cache with 64 byte lines has 1024 cache lines. Cache mapping is the method by which the contents of main memory are brought into the cache and referenced by the CPU. The mapping method used directly affects the performance of the entire computer system. Later, we will look at each of the following: direct, full associative, and K-way set associative. Here are some questions that you should be able to answer from watching the video. And that is a wrap.